Hello, my name is Rafael Belchior. I'm a PhD student at Técnico, Lisboa, and I'll be presenting you ongoing work, self-sovereign identity-based access control. This work is the result of a cooperation between Técnico, Lisboa and the University of Regensburg. The motivation of our work are data breaches and user privacy. Hundreds of billions of Facebook user records were exposed last year, causing great financial damage and great trust damage. The data that we have indicates that data breaches are increasing in quantity and severity. Furthermore, organizations are sometimes fined because they violate their users' privacy, as we could see on the news. So to resolve these problems, we are relying on an identity management paradigm called self-sovereign identity. This paradigm states that each user should have full control of their data and be able to disclose selectively their data. So we apply concepts from self-sovereign identity to conventional access control model. There are two central concepts around SSI, decentralized identifiers and verifiable credentials. Decentralized identifiers represent identities and allow peer-to-peer trustable interactions. Typically, they are routed on a verifiable registry like a blockchain. Verifiable credentials are the digitally equivalent of physical credentials. They allow a standard way of expressing claims in a way that is machine verifiable. These verifiable credentials can be expressed, their claims can be expressed via verifiable presentations, where metadata and proofs for a subset of claims are sent in a peer-to-peer way. We provide a way of combining these concepts with access control models. Access control models provide selective access to a set of resources under a specific set of conditions. So a user that wants to access a certain resource needs to have their attributes fulfilling a set of conditions, which are expressed on access control policies. This figure depicts the components of our solution. A user has verifiable credentials issued to him or her by an identity manager or an issuer. The user has a DID that identifies him and is routed on a verifiable credential registry. So if a user wants to access a particular resource, he sends a verifiable presentation to the access control model that calculates if he should have access based on the policy on that resource. So our access control system allows to map verifiable credentials to access control policies by encoding access control policies in verifiable presentation requests. Those requests are sent to the user, who then returns a verifiable presentation. In case that presentation is valid, then the user might access a certain resource. The flow that we have depicted here was the flow that we were illustrating on the other figure. So a user has access to a resource when he provides a verifiable presentation that encodes a specific access control policy regarding that resource. We tested our solution on a quality chain, an European Union project. In this project, Alice, which is a student from Técnico, wants to access a specific resource from the quality chain platform. She holds a master's degree, and that degree is encoded by a verifiable credential that was issued by EST, Técnico, Lisboa. For this to happen, quality chain requests Alice to prove that she holds that verifiable credential, and Alice can do that by sending a verifiable presentation. Upon receiving the verifiable presentation, quality chain checks its validity. If it's valid, it allows Alice access to quality chain. We tested our solution and we concluded that the bottleneck is in issuing credentials, but that is fine because we foresee that users do not need a huge number of credentials. We also checked that the end-to-end access control request and authorization takes 0.9 seconds in a peer-to-peer decentralized way. Thank you for assisting.